Hey, this is Math 6, Unit 7, Lesson 2, Points on the Number Line. We're going to plot some positive and negative numbers today on number lines and see what those things mean. So activity 1, it says a point on the number line. Which of the following numbers could be B? So which ones could be B? So we're looking at where B is, first of all, and we can see that it is between the 2 and the 3. Okay, so B is going to be larger than 2 but less than 3 based upon where that is. So a number like 2.5 certainly seems to come between 2 and 3. That's like 2.5. That would be just fine. What about 2/5? What is 2/5 as a fraction? The fraction is 2/5, sorry, but as a decimal, this becomes what? It actually becomes 0.40. So 0.40 as a number is going to be over here. Think about 1 and dividing it into 5 sections. So we go 1, 2, 3, 4, 5. 2/5 would be right there at that point. So that's definitely not going to be 2.5. So that's a no for that one. 5/2 is interesting because, again, this is an improper fraction. So how many 2's are in 5? Well, there are 2 whole 2's because 2 times 2 is 4. And 5 minus 4 is 1, leaving you 1 left over for 2.5. So 5/2, written as a mixed number, is 2.5, which is the same as about 2.5. And again, this is about 2.5 right there. So this one looks just fine. 25/10. Well, how many 10's are in 25? 10 times 2 is 20. And then 25 minus 20 gives you 5 left over. So 2 and 5/10. Well, 5/10, if I'm not mistaken, is the same as a half, so the same as that. So that's going to work just fine. And the 2.49. Well, is that 2.49? It certainly could be. The question is, what is it? It's what it could be. 2.49 is not that far away from 2.5, so I'm going to say it could be that one as well. Sure, why not? Let's look at activity 2. What's the temperature? Here are 5 thermometers. The first 4 thermometers show temperature in Celsius. Write the temperatures in the blanks. So we have temperature here, and we see that we're going up. 0 is right there. Okay, so we're up at +1. So we would say this is 1 degree Celsius. On the second one, we've gone from 0 to -1 to -2. So we're right here. This is going to be -2 degrees Celsius. The next one, we're going up, 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 1, 2, 3, and we're already at 3, but not to 4, so we're somewhere right in between. So we're halfway, so 3.5. We would say 3.5 degrees Celsius. Now, knowing that going up is a half, what about this one? Here we're going down, and we're in the negative section, right? So if that's 1, think about what's half of 1. Half of 1 is 0.5, but this is negative, so don't forget that. This is going to be a negative 0.5. And if you get confused, think about this as a dollar. What's half of a dollar? 50 cents. Okay, that's why that's 0.5. And for E, it says, well, the last one's missing some numbers, write them in the box. So we're starting here at -20, and we can see for the most part, it looks like we're counting by 5s. So we have -20, which makes this a -15, a -10, a -5, and here we're at 0. So 0, -5, -10, 15, 20, so 5, 10, 15, 20. And going up, we have 0, 5, 10, 15, 20. So that's how we'd fill it in if we're counting by 5s. Okay. Now the next question on the next page says that Elena says that the thermometer shown here reads -2.5 degrees Celsius because the line of the liquid is above -2. Jada says 1.5. So Elena says -2.5 degrees Celsius, and Jada says -1.5 degrees Celsius. So the question is, what does that mark indicate? That's what we're asking. Is it -2.5 or -1.5? Well, in our case here, if you think about how far has it gone down, it's gone down one whole one, and then it's gone down a half of one. So it's definitely going to be, with Jada, we agree with her and say this is negative 1.5. Negative 2.5 would actually be here. You have to go 1, 2, and a half. This is where negative 2.5 is going to be. So the indicator here is at negative 1.5. So don't get confused with the thermometer. Just because it looks like it's going from there to there, you still kind of measure it by looking at what's from 0 and saying, okay, that's going to be there, if it helps you out. One morning, the temperature in Phoenix, Arizona was 8 degrees Celsius, and the temperature in Portland, Maine was 12 degrees cooler. Cooler means it's going to be lower than 8 degrees. What was the temperature in Portland? So, to do this one here, we think about, we started at Phoenix being 8, and cooler means it's going to be less than, so we're going to go to decrease the temperature 12 degrees. So 8 minus 12 becomes negative 4, and we're doing degrees Celsius. So in Maine, the temperature was negative 4 degrees Celsius when it was 8 degrees Celsius in Phoenix, Arizona. Alright, says your teacher is going to give you a sheet of tracing paper on which to draw a number line. Follow the steps to make your own number line. Use the straight edge ruler to draw a horizontal line. Mark the middle point and label it as 0. And to the right, we're going to draw tick marks that are 1 centimeter apart, and we're going to label 1 through 10 to show the positive side. So the idea is we take a ruler, and I forgot my ruler here today, okay, and we're going to draw a straight line, like so. Again, not perfect, but you'll do a straight line ruler. We're going to put a mark where 0 is going to be, and then we're going to make some points for 1, 2, 3, 4, 5, 6, and you'll get up to 10 if you can. Okay. The next thing says fold your paper so the vertical crease goes through the 0. And the two sides of the number line match up perfectly. So we're going to fold this up at the 0 point. Okay, let's see if I can get this right there. And I want the line where it needs to be. So in doing that there, I folded it over, and you can see the line, and now it says use the fold to help you trace tick marks you already drew on the other side to mark the opposite side, doing the negative numbers. So we're going to use a tick mark here and write negative 1, tick mark there, which is going to be at negative 2, a tick mark there, negative 3, tick mark there, negative 4, tick mark there, negative 5, and tick mark there, negative 6. Okay, so now I have tick marks that are equally apart, spaced apart from their counterparts over here on the positive side. I have the positive ones and the negative ones right here. This is my positive side and my negative side. I try to live more over here if possible. Alright, let's look at what the next thing says to do. Turn our page. It says use your number line to answer these questions. And of course my number line doesn't go all the way to 10 like they asked. That's okay. It says which number is the same distance away from 0 as the number 4? So talking about distance, that is, it's the same distance from here to here as it is to something else. Well, the same distance from 0 to 4 is going to be, when I fold it over, you can see it, it's at negative 4. So 4, I can circle it just to show you here. So I circle 4, then what number does it end up being the same distance from on the other side? Can you see our circle? There it is, coming through, negative 4. So, in terms of distance from 0, negative 4 is the same distance as regular 4 from 0. Which number is the same distance away from 0 as the number negative 7? Now I didn't do a negative 7, but it's going to be the opposite number, be a positive 7. Two numbers that are in the same distance from 0 on the number line are called opposites. Find another pair of opposites on the number line. Again, you could pick any one you want. You could do negative 1 and 1. Those are a pair of opposites. You could do 5 and negative 5. Those are a pair of opposite numbers. Either one, any one of those works. Okay, determine how far away the number 5 is from 0, then choose a positive number and a negative number that is each farther away from 0 than the number 5. Okay, so 5 is here, and we wanted to pick a number that's further away from 0 than that one. I could simply pick 6, that's going to be further away, that's a positive one. And in terms of a negative one, I could do -6 or even -8, whatever it's going to be. I could do -8, that would work too. Those are both farther away from 0 than the number 5. You see, I couldn't pick anything between here and here because those would be the same or less than. So I need to look outside of that area to find something that's further away than 5 is. For E, determine how far away the number -2 is from 0. Well, it's right here. I'm going to say it's a whole 2 spaces away. Then choose a positive number and negative number that is farther away than -2. So if we're looking at -2, we want to be further away than that one is, so I need to be on the outside of this. I could say -4, that's outside of that area, and I could say +5. Sure, there we go. So we're going to pause there so your teacher can check your workout and see how you're doing. Number 3 says, here is a number line, which some points labeled with letters. Determine the locations of P, X, and Y. Alright, if you get stuck, trace the number lines and points and then fold it over. So, let's do that here. We're going to take our number line here. I'm going to trace this like so. Trace that. And we have 0. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll put down our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I take my tracing paper and flip it over, I can line the 0 up with a 0. And now I can see where my points are going to be. P is right here, and it's on that backwards 2, so we'll say P is at -2. X is right here, so X is between 4 and 5, so we'd say X is at -4.5, and Y seems to be between 7 and 8, so Y is at -7.5, based upon flipping that number line over. So we have -7.5, -4.5, and -2. And again, we could do it by recreating that line there and making sure we had 1, 2, 3, 4, 5, 6, 7, 8, 9, like so. Again, not perfect numbers there. That's why it's good to trace it to get it better. Okay? And that's what we have. -2, -4, -5, -7, -8, -6, -3, and we're good. Alright. Lesson summary. Let's look at the lesson summary real quick. Here's a number line labeled with positive and negative numbers. The number 4 is positive, so its location is 4 units to the right of 0. So if it's positive, it's to the right of 0 number line. The number -1.1 is negative, so its location is to the left. So negatives to the left, right? These would be our negative numbers, and these would be our positive numbers over here. We say that the opposite of 8.3 is -8.3, and the opposite of fractions work the same way. -3/2, the opposite is 3/2. Any pair of numbers that are equally far from 0 are called opposites. So equally far from 0 are what opposites are. Okay, and basically it's a positive and the opposite the negative number there. That's the big thing, okay? Now, one thing to keep in mind here, you have to do this today, is that when we're talking about fractions, remember, to locate a non-whole number, like a fraction on a number line, you can divide the distance between two whole numbers in fractional parts and then count the number of parts. For example, 2.7 can become 2 7/10, and then the 2 and 3 can be partitioned into 10 equal parts. That's the tenths part there. So you take the 2 and the 3, and then you make it into tenths. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And to find 7 tenths, you'd count out 1, 2, 3, 4, 5, 6, 7. And that becomes 2 and 7 of the 10 parts there. and that can be found on a number line just like anything else. A little more complicated, takes a little more time to do that properly, but you will need to be able to do that on the homework, on number 2 on the homework. You'll have to do that today, okay? So all fractions and their opposites are called rational numbers. So fractions and decimals and the opposites are all rational numbers there. And so just keep that in mind. We're going to pause there for the day, and you're going to work on your homework. We'll come back and check it together in just a few minutes. All right, here's our homework for lesson 2. For each number, name its opposite. So here we have a -5. The opposite of -5 would be a +5. Here we have a +28. The opposite would be a -28. Here we have a -10.4. So the opposite is a +10.4. Here we have a +0.87. So the opposite would be a -0.875. I'm not even sure what I just said. The opposite of 0, there's not one. We would say none. And the opposite of -8,003 would be +8,003. Plot the numbers -1.5, 3/2, -3/2, and -4/3 on the number line. So -1.5, it's going to be here at the halfway point, and we can write -1.5 no problem. Want to do 3/2. Okay. So 3/2 means I'm dividing things into halves. So this is a half, this is a half, and so half segments means I'm going to count out 3 of them. 1, 2, 3. So 3/2 is located right there because I broke the whole number into whatever the denominator was, which was 2, into halves, and I counted out 3. Okay, there's 3/2. Now -3/2 would be the same idea. We go from 0 to 1, we cut that in half. 1 to 2, we cut that in half. So counting out 3/2, we would go 1, 2, 3. So here's -3/2 right there, which is the opposite of 3/2. Now 4/3 on the number line, a little different, -4/3. 4/3 means we're going to take the number, the third number, or the number, and we're going to divide things into 3 parts. Okay, so I've already marked on a little bit here, so let me erase this real quick. Okay, and let me divide this into thirds. Do I have another color me? I do. Hey, what do you know? Let's use I'll use a highlighter for thirds. So thirds means I go 1, 2, 3, 1, 2, 3, and I can look at the whole numbers as being the bigger ones here too. Nope, not a problem. Okay. So because I'm doing negative, we're going to count out 4 1/3 segments. So 1, 2, 3, 4. So -4/3 is actually right there on that space and that spot. Okay, so that's how you break that apart there. -4/3. It would have been nice if it wasn't doing thirds and halves. Your hash marks might be a little bit cleaner, but I use a different color to help show that. Okay. All right, plot the following points on a number line. So we're going to make a number line, like so. There's a number line. We're going to start with a 0, and I can see I'm going to go down at least to -2, and so I'll go here, go -1, -2, +1, +2. The first number is -1.5, so that's going to be here. -1.5, which we've just done on the one right before it. The opposite of -2, the opposite of -2 is +2. So there's +2 right there. The opposite of 0.5, well, 0.5 is here. The opposite is at -0.5. We'll plot that there. And then -2 is just simply old -2, and there it is. So there we go. Got them all plotted. All right, represent each of these temperatures in degrees Fahrenheit with a positive or negative number. 5 degrees above 0, so that would be +5. 3 degrees below 0, -3. 6 degrees above 0, +6. 2 3/4 degrees below 0 is -2 3/4. And then order the temperatures above from coldest to warmest. So, which one's the furthest away from 0? Would be our -3, followed by the -2 3/4, followed by the 5, and our greatest number is 6. And again, if you're not sure, Probably if you mess anything up, you probably mess it up right there. But again, starting with 0 as your kind of center point there, -3 is further away than -2.34, which makes it actually colder. Okay? Alright, let's turn the page for the back side here. We have some equations to solve. The equations are a review from Unit 6, Lesson 5. So, let's solve some equations. These equations aren't super nice, but we can do them here. For A, we have 8x equals 2/3. So, to solve this, we're going to divide both sides by 8. Divide both sides by 8. So, x is actually equal to 2/3 divided by 8. And when we're dividing by 8, we're also talking about multiplying by the reciprocal. So 1/8. So 2 times 1 is 2, and 3 times 8 is 24. So I can say x equals 24, or I can reduce that to 1/12. So that's A for you right there. For B, B is 1½ equals 2x. Let's rewrite this as a improper fraction. 2 times 1 is 2, plus 1 is 3. So I have 3/2 equals 2x. We're going to divide both sides by 2. So over here I actually have 3/2 divided by 2 equals x. Now when dividing by 2, I can think of that as multiplying by the reciprocal. 1/2. This is like 2/1 equals x. 3 times 1 is 3. 2 times 2 is 4. So 3/4 equals x. And there's letter B. For C, we have 5x equals 2/7. So I'm going to divide both sides by 5. So I have x equals 2/7 divided by 5, or 5/1. And we write that as 2/7 times the reciprocal. And then we get 2 times 1 is 2, 7 times 5 is 35, so x equals 2/35. That's letter C. For D, we have 1/4 x equals 5. So in this case, I'm going to multiply just by the reciprocal right away. So this is eliminated, so x equals 5 times 4 is 20. And finally for E, we have 1/5 equals 2/3 of x. To get that separated, I multiply both sides by the reciprocal. Right, so 3's cancel, 2's cancel. I have x left over here. 3 times 1 is 3, and 2 times 5 is 10. So 3/10 equals x. Alright, number 6, write a solution to each equation as a fraction and a decimal. So, to get those separated, I divide both sides by 2. So x equals 3/2, that's a fraction. As a decimal, 3 divided by 2 is actually equal to 1.5. For this one, I'll divide both sides by 5. So y equals, my fraction is 3/5. And then 3/5 is the same as, think of it this way, I could do 3/5. Now if I multiply that by 2, I end up with 5/10. And 5/10 is what? 0.5. Oops, why did I do 5/10? I get 6/10. Sorry about that. Just got ahead of myself. So 6/10. And here, we're going to divide both sides by 0.3 by 0.3. So, as a fraction, 0.3 is dividing 0.3, goes into 0.009. Move it over, move it over, move it up. 3 goes into 0, 0 3 times. You end up with 0.03 as a decimal answer, but that is 3/100ths as a fraction answer. And finally, number 7, there are 15.24 centimeters inside of 6 inches. How many centimeters are in a foot? Well, it helps if you know that a foot is how many inches? A foot is 12 inches, right? So that's what? It's doubling this. So times 2 gets you to a foot. So we're going to take the 15.24 and we're going to multiply it by 2 because 1 is 6 inches and 2 is a foot. So we have 8, 4, 10, and 30.48 for how many centimeters are in 1 foot. Now a yard is made up of what? 3 feet. We already have 1 foot, so let's multiply that by 3 in order to get the yard. So 4, 2, 12, 13, 14, carry the 1, and 9, we get 91.44 centimeters. So that's our first answer, and there's our second answer. Alright, that's it for the day. Hope you have a great day, and we'll see you next time.